So good morning, good afternoon, good evening, depending on the time zone, wherever you are. Uh, it's a great opportunity to come and speak over here in this event. So the topic for discussion today is going to be digging the attack surface of Microsoft rich text format. So primarily, we are going to discuss this from the OLE standpoint, right? So before we move ahead, a bit of an introduction. So my name is Chintan Shah. I've been working with McAfee for quite some time. I've been into the network security industry for about 15 plus years now. I've kind of spoken at many other security conferences. Recently, I spoke at MR, and before that, I've been speaking at other international conferences as well. My primary focus as a part of my job in McAfee is basically analyzing malwares, APDs, exploits, reversing, primarily fuzzing and vulnerability research. I hold multiple patents on exploit detection techniques, and one of my core job responsibility is to translate the research into the product new detection method, product improvements, and improving the products with new detection techniques and methods. That's what I basically do. So let's see what is in the agenda for today's session. So we are basically going to touch upon the Microsoft rich text format. We are going to touch upon the overview as well as what has been in the past with MS RTF file format. We'll discuss a little bit in detail about object linking and embedding and how this has been exploited by attackers. We'll touch upon OLE attack surface as well, and how this has been abused by attackers to target Office platform. We'll discuss in a little bit more detail about MS RTF file structure parsing and how to go about inspecting the RTF file format on the network. And how can we build automated inspection mechanism to classify MSRTF files. We'll talk about the engine components, architecture, inspection flow, and then we'll end this talk with example engine output and what we've seen as initial results when we ran this tool over many of the exploits that we have tested. Right. So over the past few years, we have had many exploits that target Office platform, and out of these attacks, a lot of these attacks have been exploited in the RTF file format through the RTF file format. So RTF has been one of the more adapted file format recently over the past few years, and many attacks out of this high impact attacks have been exploited via RTF. So it's pretty popular among the attackers, and there are a few reasons for it. During the last year, May 2020, the US government basically shared a top list of vulnerabilities exploited since 2016. So they've shared the popular exploits which have been used in targeted attacks, and many of these exploits all of these exploits have been on the Office Office platform. And one of the top observation that came out of these exploits is all of these exploits were primarily targeting Microsoft's OLE. So OLE has been one of the feature which has been targeted massively by attacker because of the attack surface that it exposes, right? It exposes virtually a huge attack surface for the attacker, and without writing any form of complex shellcode, attacker can easily deliver the exploits targeting this feature. They can build the exploit, they can craft the exploit, and deliver it to the victim, and it is super easy to exploit this kind of vulnerabilities which Office OLE feature exposes. So that's one of the prime reason why Microsoft's OLE has been one of the top attack vector over the past few years, which also is a conclusion out of what has been shared by US government. So the question is why RTF? What are the reasons behind the RTF file format being so popular among the attackers? So one of the reason is that it is very versatile format. It is very attacker friendly. Another major reason is that RTF is able to embed many object types. RTF can host many object types like images, video, docs, ActiveX controls, can host like other objects, fonts. So in fact, this feature is a part of entire Office application suite. Now, RTF having the feature of OLE doesn't mean that the other file formats of the Office application doesn't have cannot be exploited. They have been exploited as well. But there are few reasons why RTF kind of stands apart from other file format in terms of attackers popularity among the attacker and why it has been used so massively. One of the reasons is that it serves as a carrier for other file format exploits. You can easily embed many file formats in the RTF file format and deliver the exploits to the victim. Other reason is that RTF file format is because of its structural complexity and parsing complexity. It is kind of very limited. The visibility of RTF file format in terms of structure parsing is very limited among the perimeter solution. So, for instance, IPS doesn't have a full parsing or full visibility into the structure of the RTF, and that's the reason attacker primarily choose to use it more than any other file format. And attacker can craft the file format, RTF file format, in such a way that it can evade a lot of static detections. So if you see the distinction between the RTF file format and other file formats which Office application has, for example, a docx or other XML, OXML file format versus the compound binary file format as well as the RTF. One of the prime difference here is that RTF file format can be obfuscated heavily to evade the detection, right? And which it is kind of very unlikely as with the other file format. You can nest the control words. RTF is primarily made up of control words, as we'll see in the next few slides how the structure looks like. But because of the heavy nesting of the control words and introducing obfuscations, it is very easy for the attackers to bypass any of static detection mechanism and hide malicious resources in there. So these are some of the primary reasons why RTF has been popular among the attackers, and because of the, as I said, because of the limited structure awareness among the perimeter security devices, and because of the nested structure, IPS and other perimeter security solutions don't choose to inspect RTF as deeply as it should have been. So these are some of the reasons why RTF has been so popular and go-to file format for the attackers. Now, what are the primary attack vectors in RTF? So there are a couple of them. Predominantly, in fact, there are many attack vectors, but primarily there are a couple of attack vectors which I would like to kind of highlight here. One is parsing engine flaws. So as I said, RTF is complex structure with nested control words. As you can see on the right side, there are many control words in RTF, about 1,800 plus control words in RTF, and many of them are largely unexplored. So any of these control words could have a parsing vulnerability, right? And the other thing is all these control words are able to consume streams of data. Now, what these mean for the attacker is that attacker can craft the RTF exploit in such a way that they can get the RTF MSRTF parser, ignore the control word. At the same time, they can embed the malicious resources like shellcode or decoy document or any other executables within the control word stream data. Now, while parsing this, attacker can choose to embed these malicious resources to hide them, as well as attackers can basically craft the exploit to craft the RTF to exploit control word parsing vulnerabilities as well. So we've had many such control word parsing vulnerabilities in the past. Other primary vector attack vector is object linking and embedding. So this as we discussed a few slides back, this has been a massive attack vector. It has been exploited heavily in the past by attackers, and most of them have been a logic flaws where attackers were able to exploit one or the other parsing vulnerability or logic flaws in the OLE control. So what OLE allows attackers to do is it can allow attacker to link to the external object. That's one of the serious drawback of OLE. If you are able to find an OLE control which allows you to link your RTF file to the external world or external file anywhere outside, then virtually you can download any file, invoke a respective resource handler, and then you can basically execute an arbitrary code. So that's what we have been observing. The recent trend has been so far over the past few years. So object embedding allows attackers to basically exploit memory corruptions vulnerability, or there have been many cases in the past where it aids the further exploitation in terms of crafting the process heap memory, or aiding the further exploitation process. So attacker could basically embed a file, any other file within the RTF, where it can help to craft the memory of the process and then aid further exploitation. So we have had many such cases in the past. So how does it look? So this is the first look at the RTF. Basically, if you see, this is just less than 1% of the document. Even if you write a couple of words of text, the RTF document is kind of so big that what you've been seeing here is less than even just a single 1% of the document. So imagine the volume of data to process if IPS and other perimeter security devices has to inspect this file format. So because of the performance issues and everything, other issues, the perimeter security devices hasn't been too focusing on deep inspection of RTF files, and I think that's one of the fact that attackers have been taking advantage of. So here are a couple of examples where attackers have been abusing the control words. So if you see on the right side, both of these control words, for instance, level text control word as well as data store control word, both of these control words have been abused to either embed a shellcode or embed an executable within that. And if you see the bottom, other control word, the RTF called pre-fragments have been used to embed a shellcode as well. So many of these control words, in fact, have been used. I've just quoted a few examples here, but this is what attackers can do with the RTF control words. They can hide malicious resources within the control word stream of data, as well as they can obfuscate the control words stream to break immature parsers, right? And it can even bypass many of the static AV detection, which are kind of based on signatures. So attacker can basically craft the RTF file in a way that can break the detections which are kind of based on static signatures. So these are primarily examples where the control words have been abused. So let's take a look at how object linking and embedding have been abused in the past. What is it? How OLE is initialized, and what are the attack surfaces? So object linking and embedding is basically the infrastructure which is built by Microsoft for having interoperability with the third-party vendors. It is entirely built on Microsoft's COM infrastructure, which allows you to create an object which is allows you to either embed an object which is created in other application to be embedded into a container application. So we call here in our case, RTF is basically a container application where we create an object in other application. For instance, we create an object. It could be a PDF file, or it could be an ActiveX control, or it could be OXML file, right? And it allows you to embed or link these objects within the RTF. So what it results into is basically it will provide a richer user experience, as you can see here on the right side. ActiveX scroll bars, or you can embed ActiveX controls. You can embed other documents into the RTF, right? You can link your objects, link your RTF to the external objects as well via linking capability. So all these functionalities are kind of provided by Microsoft's OLE infrastructure, and what it results into is it consequently results into increased attack surface, because there are kind of many COM objects in the Windows. Even if you install software, the vendor will register a COM interface, COM objects into your system, and if that COM object comes out to be a vulnerable COM object, then essentially your entire Office security is compromised. So let's take a look at it, how we can do embedding and linking. So if you look at the figure 1, you can just insert an object, and you have an option to insert basically a lot of variety of documents into RTF. You can basically embed many form of documents. And what it will result into is an object control word with a nested control word called OBJ-EMB. So OBJ-EMB essentially means that there is a embedded object. Now, if you come across an object control word in RTF, as you can see at the bottom, when you embed a document, PDF document, right? It basically turns out to be object control word followed by OBJ-EMB control word. And then when you link an object, link your RTF to any external object, right? It could be any URL, then it will come out to be an object control word followed by OBJ auto link, or it could be an OBJ link as well, link or auto link. It could be both of them. And if you choose to embed an ActiveX control, then this is exactly what you'll get as you've been seeing here. You will get an object control word with OBJ OCX, and an OBJ class will determine what kind of object it is. If it is a PDF object, you'll see OBJ class as acrobat.dc, depending on your version. If it's a linked object, then you'll basically see OBJ auto link. So you'll kind of see something like this over here. And these are the important control words when we are talking about inspection of RTF over the kind of building automated inspection tool to classify RTF files. So here you can see some of the important OLE control words. So OBJ-EMB indicates the embedded object, as you can see on the left side, object control word followed by OBJ-EMB control word, and OBJ class kind of determines what kind of object is it, right? If it is a PDF, it could be Acrobat. If it is a Word document, it could be a Word document. If it is a OXML, then it could be something else. If it's package, then it could be a OBJ class is equal to package. It's exactly what you can see on the left side of the screenshot. So other important object is that OBJ OCX, which represents which indicates that there's a ActiveX control embedded inside RTF file. If it's a link object, as I said previously, it will be object followed by OBJ auto link control word. It could be a OBJ link as well. So these are some of the important control words related to OLE, which should be taken care of when we are building an automated classification tool to classify RTF files, because we will need to extract data from all these files, and then we will need to inspect it further. So if you look at the screenshots closely, there is a control word called OBJ data, which is a data that is to be rendered by the OLE control. And that rendering is primarily based on CLS ID, which is determined by the OLE32.dll, which is kind of handles the OLE infrastructure in the Office suite. So some of the important control words. And let's quickly take a look at how this object initialization and loading happens when we embed any object into RTF file. So as I said, OLE32.dll is in proc server for instantiating OLE object, right? It basically handles the COM instantiation and loading the COM DLL into the memory. OBJ class and OBJ data is basically the program ID mapping to OLE control. As you can see in the previous slide, if you see OBJ class is what indicates the program ID, right? So that string is primarily known as program ID, based on which OLE32.dll will call a function called CLS ID from program ID, as I've highlighted on the right side. And once it gets the class ID, unique class ID, it will map that class ID into the registry, and then it will pick up the DLL from there. Basically, it will load the DLL into memory, and then it will follow the process which I've highlighted at the bottom. So it will basically go and instantiate a COM object using co-create instance, and then it will basically hand over the OBJ data for rendering. So this is how the OLE object initialization takes place into the Office suite, right? Now, this opens the wide attack surface as well, as far as attackers are concerned. This opens a huge attack surface for the attackers, because if you see, if you think about it, any DLL ID, any DLL which is mapped to the CLS ID could be loaded into the Office file. So what attackers can basically supply here is the class ID as well as the data which has to be rendered by the COM object. So let's little bit talk about object linking. So as I indicated earlier, if you just go to the object and if you click on create from file, and then if you provide a file name, in the file name, you just need to provide a URL basically, and then you just have to check link to the file. So you are primarily linking an object. And what it results into is, as I said, previously, it will look something like this. So how the data is stored when a linked or embed object is when an object is linked or embedded into RTF. So this is how it looks like. So you'll have an object control word, which primarily means that there is an object either linked or embedded, which is determined by the nested control word, which follows the object control word, right? So there is an object control word, and since we linked it to the external file, we'll see OBJ auto link there. If you see in the specs, it is basically a type of a auto link, OLE auto link object, which will which links your RTF file to the external world, right? External resource, and then when you open the document, it will basically download the file, and then it will invoke the respective handlers. For example, if you have came across, if you have seen the 2017-0199, which was kind of infamous vulnerability, which was exploited since until kind of 2019. It linked that RTF file to the external HTF file, and then it used to basically download the HTF file and then invoke HTA handler. And then it basically ended up executing arbitrary code, right? So that's how the object linking opens the attack surface. Now, if you see OBJ class is word document.8, which basically indicates that there's a OLE2 compound document file format, which is highlighted in blue here. So the one which you see in red highlight is the nested control word, which is visible when you link your RTF file to the external resource. The one which you see highlighted in green is basically the OLE 1.0 native data size, native data. It is basically OLE 1.0 native stream, and the entire object data is primarily stored in OLE 1.0 native stream, right? And the last 4 bytes of the native stream is the OLE 1.0 native data size, so which indicates the size of the OLE control that you have that the RTF carries. And what follows next is the OLE compound binary file format. So this compound binary file format is basically the data which has the OLE is the data which has to be rendered by the application, rendered by the respective OLE control. And this is the normal doc file format. If you see the signature is DOCFILE, so which actually means that it is a compound binary file format which we used to see before Office 2007 and Office 2007 and before. So it's primarily the entire OLE data is embedded inside the OLE 2.0 format. Let's see how object embedding takes place. So it's basically very similar to the linked object. The only difference here is the control word will change. Instead of obj link, it'll have obj emb, right? So here what I've shown here is the OXML file embedded within the RTF file. Now OXML file here was basically an exploit which was delivered via RTF, right? So if you see, OXML file has been embedded inside the OLE2 compound document. Now, if you see the program ID string here is word.document.12, which basically indicates that there is a OXML document which is embedded inside the RTF file format. Now, along with the RTF, along with the OXML, there could be many other file formats which could be embedded inside RTF. For example, flash files, PDF documents, ActiveX controls, images, and stuff like that. So how this helps attacker is this allows attackers to use RTF as a carrier for other file formats, which is essentially a huge attack surface, since RTF has a limited visibility over the network and this limited visibility within the IPS or within the perimeter security devices. This basically hides your actual exploit within the RTF, and then it allows you to deliver it to the victims. So if you extract the OXML file and inspect this file, you can see there's a shellcode which is embedded inside. There was a malicious ActiveX control, and if you inspect this ActiveX control, there was a shellcode which was embedded inside. So essentially, attackers were able to deliver the OXML exploit via the RTF file format. So that's what embedding will basically allow you to do. So talking about the OLE packages, this is another attack surface which has been exploited widely by the malicious actors. So what it allows you to do is it will allow you to embed malicious payloads. Now if you see packages are basically if you click on the object and if you go to the packages, you can embed basically any file format, right? Now there is no particular file format which is associated with OLE packages. Now it could be either VBA script, it could be JavaScript, or it could be executable. It could be an XML file. So there is no particular data format associated with the packages. So attacker can basically come here and embed any file format which it kind of wants to, and the respective handler will be invoked by the OLE infrastructure based on the file type. So what essentially happens here is a packager.dll is responsible for loading the package data from the document and then processing the package data. Now, there was a serious issue which was reported in this OLE packages few years back. In fact, it was reported by one of our researchers that a package is basically dropping the files into the whatever files that you embed via OLE packages. It used to drop into the temp directory, and this behavior of OLE package has been abused heavily by the attackers over the past few years. So if you see here, the malicious RTF drops embedded OLE package into the temp directory, and this is exact behavior which is out of the packager.dll. So packager.dll basically processes that package data, and it'll drop the embedded file or embedded payload into the temp directory. Now, this behavior can also be abused by attacker in many ways, because there are many applications, right? We never know how an application uses the temp directory. It could basically pick up the drop file from the temp directory and then it could execute. So this behavior was used by attacker to target lot of victims. So this is something which we need to take care about when we are building an automated tool for RTF classification as well. So we need to inspect the OLE packages, see if there is any package data there, and then we need to extract and then extract the file, and then probably we can inspect it through some other engines or a sandbox. So summarizing what has been the OLE attack surface, primarily attackers have been abusing. So one is CLS ID based loading of DLL. So as I indicated, there are many OLE objects in Windows, and any logic flaw in any of the OLE object could lead to the entire office compromise. So what attackers can supply here is they can supply the CLS ID, right? They can supply the relevant data to be processed by that DLL, and this DLL could be either used to build an entire exploit. It could help attackers to bypass Windows mitigations, or it can help attackers to get a memory corruption, exploit memory corruption flaws. So this has been one of the primary attack surface. OLE packages has been used by attackers to drop the payload on the disk because of the functionality that it provides, and since no file format is associated with packages, it can basically embed any form of files. And other attack vector which has been in the OLE objects is the logic flaws primarily. So there could be a parsing logic flaws in the attack in the OLE objects. For instance, there could be a OLE object which can process your XML data, right? So if there is any parsing flaw in that OLE object, basically it could lead to an office compromise. So that's one of the fact that attackers have been taking advantage of, and many OLE objects have been allowing attackers. It can allow attackers to link your RTF to the external file, external resource, and it can invoke the respective handlers to execute that external resource. So if it is an HTA file, it can invoke mshta.exe to execute the file, execute the HTA file. So that can lead to arbitrary code execution. So let's kind of touch upon how we can build RTF file structure and how we can build the parsing and inspection. So primarily what we need here is a robust RTF document parser, which can parse the destination control words and extraction of, and it can extract data streams out of them. It is critical for the parser to handle the stream obfuscations, because attackers can take advantage of the control word obfuscations to bypass evade the static detections, AV detections, or perimeter detections if it is available in any of the perimeter solutions. So we need a robust RTF document parser, and since all the OLE objects are embedded into the OLE2 compound binary file format, compound document format, we need a compound document format parser as well. So we need a OLE2 parser. So primary three parsers we need. Other is OLE packet structure parser for extracting the embedded payload and sending it somewhere else for analysis. Could be into the sandbox, or could be any other AV detection solution. So we need a three parsers. One is RTF document parser. We need a OLE 2.0 compound document parser, and we need a OLE package structure parser. So this three parser could basically allow us to extract the data from the RTF file and inspect relevant sections of the data. And other modules, other inspection modules can be integrated if needed. So for instance, if there is an OXML file embedded, we could have OXML analyzer which can inspect the OXML file. We could have PDF analyzer plugged into this RTF inspection module, which can primarily inspect PDF document, or similar for the flash file document. So any other file format analyzers can be plugged in into this, and which can help us identify, extract, and send it to the relevant file format analyzers. So what is our detection focus here? Detection focus is to detect weaponized exploits. So we want to kind of identify exploitation methods instead of just vulnerabilities. For instance, if RTF links to external resource, STF file or a JS file or any executable file, then we should basically, it should be an eye catcher. Basically, it should be looked with a little bit of suspiciousness. So we want to detect the exploitation methods. We want to identify, we want to extract all the data. We want to even inspect non-OLE control words as well. And there are few non-OLE control words, for instance, data store or theme data or any other control words which has been abused by the attacker. So we want to inspect them as well. And there are many other RTF control words which can carry streams of data. So any of these control words can be abused. So you want to extract the data and inspect them as well. We want to extract data streams to OLE control words, and we want to inspect them as well. So all the OLE control words are primarily OBJ EMB, OBJ OCX, OBJ link, autolink, and OBJ HTML, stuff like that. So all these data, all these control words will carry OBJ data. We'll have OBJ data, and all this data streams needs to be extracted and inspected further, right? And one of the other primary thing is we want to also look at the RTF overlay data. So what data is basically data which is appended at the end of the RTF file, and many times it has been used to hide shell codes or hide any other malicious resources which can help attackers to basically execute the attack. So in terms of OLE 2.0, we want to inspect the content stream because that's where the embedded file will be. If attacker basically embeds OXML file or PDF file, you will find the PDF file in the content stream of OLE 2.0 document. So we want to extract OLE 2.0 data stream, and we want to extract all the object storage and object streams, and we want to inspect that further to see if there is any malicious content there. So this is the high-level block diagram. So we have an RTF structure parser, we have an OLE structure parser, we have compound binary file format parser, we have Office OXML parser, we can have flash file detection, PDF file detection, we can have a sandboxing solution which could be plugged in into this module. So this will kind of and this is kind of scalable. You could plug in other modules as well, which as per the inspection requirements, and this will help us to kind of parse the RTF and then use any other modules which can inspect other file formats to see whether the RTF file comes out to be malicious or not. So this is the flow diagram a little bit more detailed. So we want to inspect the OLE objects. So we want to look at all the OLE objects, OLE EMB, OBJ EMB, Autolink, OCX, affairs control. You want to look at OBJ class, which is a package. And out of that, we want to look at the many other OBJ class arguments as well. We want to look at what are document.8, 12, rich acrox document.dtc, which means basically a PDF document. So based on the OBJ class, we could extract the relevant file and then we can forward it to respective modules. So since the data is embedded into OLE but not native stream, we have to extract the native stream. And based on the size, depending on the size of the OLE2 compound document, we have to extract that and inspect all the streams for malicious data, as well as inspect the content stream for embedded file, and then we can forward the file to respective analyzers. So OLE packages, we can extract OLE packages based on the OBJ class. If we find the program ID string as OBJ class is equal to package, we could basically extract that package data and forward it to package parser for extracting any embedded scripts or any embedded executable. So at a high level, this is how the RTF inspection can take place. And of course, overlay data as well, OLE data and the non-OLE control words as well. We need to inspect them because attackers can abuse this to hide malicious resources, as I said earlier. So let's take a look at engine output and some of the initial results. So as you can see here, there is an OXML object which is embedded inside the RTF, which is OXML itself is a malicious file, and the engine is able to extract the OXML file out of the OLE2 compound document, and then it can apply the binary stream heuristics, inspection heuristics, and it turned out that the OLE file, the OXML file was which was embedded into the RTF document was kind of malicious, right? So you can see all the malicious heuristics that triggered here, eventually leading to classification of RTF file as malicious. And it was able to extract the OXML file and was able to reinspect the file for further malicious contents. So this was one of the example. Recently, last year, there was one targeted attack which targeted aerospace and defense industry. So what we saw here is OBJ class was 1.document.12, which essentially means it was an OXML document. So we went inside this OXML document and then we inspected it further, and the attack came out to be a template injection. So this basically linked this document, this embedded OXML document was linked to other OXML document to the CNC server, external source, and then it was downloaded and executed. So that the external one was a real exploit. But when we inspected this document, it came out to be a template injection technique which was used by attackers. So these kind of techniques are very important to inspect when we are classifying the RTF files. So and since this allows, as I said, to embed any kind of file format, we have to be kind of extract these files and inspect it further. So coming to the initial testing results, we've kind of tested this engine from over a variety of exploits, starting from 2012 to 2020. And we've kind of tested 15,000 exploits, around 15,000 exploits. And we've, with over close to 50 heuristics, 50 RTF heuristics, inspection heuristics implemented, we came to about 94.3% of detection rate. So we had about close to 50 odd heuristics implemented in the RTF inspection engine, which includes RTF heuristics as well as OLE compound binary file format heuristics as well as OXML heuristics as well. And false positive, we've kind of had very less false positives with this engine, 0.60% of false positive, which is very encouraging. So with that, I close this discussion and I'm open for any questions if you have.
Thank you so much, Chintan, for that great deep dive into a file format that probably doesn't get as much attention as the normal, docx files and the likes, really interesting stuff. I guess one question I have, for someone maybe getting started in this space and maybe not at the level of implementing some of the automated parsing and categorization, what sort of tools would you recommend to someone analyzing RTF files and embedded OLEs in them? I know Didier Stevens has a few popular ones there. Is there anything you'd recommend for people starting out in this space?
Yes, sure. So there are kind of RTF parsers available. So instead of kind of reinventing the entire wheel coding the RTF parsers, there are open source RTF parsers available. Kind of those who are interested to get started in this space can visit Decalage RTF parser. RTF it is basically entire suite of OLE parsing framework. But what we have kind of done here is we had to modify the RTF parser to be able to suit our requirements. So based on our needs and requirements, we have to have modifications to this parser because there could be many other corner cases which may not be covered by the open source parser. So we have to take care of that as well based on the exploits available. So one is Decalage RTF parser. There is RTF dump as well, which is another open source tool available to get started in this space. And there are many other OLE2 parsers as well. So entire Decalage Office parsing suite can be used to implement this engine.
Yeah, thanks for that. I notice your research on this subject is available on the McAfee website. I've provided a link to your blog article give people an opportunity to
Yes.
speak through afterwards as well. Okay, thank you so much, Chintan, for that. Thank you. And again, virtual round of applause from everyone.